Welcome back. What we'd like to spend a little bit of time today doing is looking at three-dimensional round objects where we won't be using Papasculdinus. We know that can be an effective tool, but it's not always available, so we can't pretend like it is. Let's start off with a half sphere. Okay. What I've taken our typical sphere and I've just chopped it in half. And our goal is to figure out where is the centroid. Where does that centroid go? We know it's somewhere around here, but that's no great mystery. The question is where. Now, we know that in the y direction, everything is fully symmetrical, so we're going to know where the centroid is. And same with the z direction. The difficulty is going to be along the x-axis. Where is the centroid? Now, the way that we find this out is we fall back on an equation we have. The equation we have, or an equation that we should know. If we take the location of the centroid and we multiply it by the volume, that is the same as taking the integral of the x-coordinate times the volume. This is in fact the definition of the centroid, or our first moment. Now, we're going to have to, in this case, use this equation. We've kind of faked it for most of the time, but now we actually have to use it. Now, fortunately, we know that the volume of half of a sphere is 4/3 pi r cubed. Well, half of that is going to be 2/3 pi r cubed. So we know that the total area that we're dealing with, or the total volume we're dealing with, is 2/3 pi r cubed. Let's write this down in equation form. Centroid location times 2/3 pi r cubed equals the integral of x dv. First question is, what's our approach going to take? And we have a couple ways to do this. The way that I think is probably the easiest, fastest, and best is we're going to take slivers in the YZ plane, perpendicular to X. We're going to take these little slivers, these little disks, and we have to figure out what their volumes are. So let's take these little disks. It's going to be the integral of X, and the volume of those disks is simply going to be the area times the depth. Well, the depth is easy. That's going to be dx, right? But let's figure out what the area is. The area is going to be, now if we need to visualize it, we can go back to an equation of a circle. Now in this case, I'm just doing the first quadrant, right? But you get the idea. And in this case, y equals, and let's say it has a radius r, is going to be the square root of r squared minus x squared. That should come back from the memories of trigonometry, I would imagine. So we're going to take the y value and we're going to square it. So the y value is r squared minus x squared. And remember, what we're trying to do is finding the area of this big disk. Okay, well, we just found the radius of the big disk. That's that y value. That's this thing right here. We're going to square the radius and multiply it by pi. So when we do this, this tells us right here the area of this disk. Might have to take a look at that to see that, but this tells us the area of this disk. Multiply it by the depth and you have the volume. Now let's go ahead and try and solve it. Now the first thing we see is we see pi's on either side. Well, we can bring those out. And normally this is kind of scary under an integral. We're really lucky here where we're squaring a square root, which those of you who've done calculus a lot makes you very happy. And we're going to evaluate this, just so you know, from 0 to r. So let's bring this, let's solve for our for our x bar, or our centroid location, we're going to get 3 over 2r cubed, which is this brought over. Now we're going to integrate this, I'm not going to say mess, but this item here, we're going to integrate an xr cubed, or an xr squared. That is simply x squared r squared over 2 minus an x cubed. So we're going to take that x times this x. Actually, you know what? Let's not kill you right now. Let's go ahead and do this in little steps. All right, so we can integral from 0 to r of x times r squared minus x squared dx. There we go. This probably feels a lot better for some of you. 3 halves r cubed. We're going to integrate the x r squared. We're going to get x squared r squared over 2 minus, here this is x times x squared, x cubed. Integrate x cubed, we get x to the 4th over 4. And we're going to evaluate this from 0 to r. Let's move this down a little bit so we can see. And we're going to end up with, let's see, over here we have 3 over r2 r cubed. Plug in an r here, so we get r to the 4th over 2 minus r to the 4th over 4. Well, that's awfully convenient. We get 3 halves r cubed times r to the 4th over 4. That equals that r to the 4th on the top and the r cubed on the bottom brings us to 3r over 8. So what this tells us is that the location of the centroid in the x direction is 3 times the radius divided by 8, or 3/8 the radius. I hope this gives you a little bit of an idea of the basic steps for dealing with 3D problems where we do have to integrate. Thank you. I look forward to seeing you soon.